Discover the latest insights on multimodal large language models, LLMs. These models excel in visual question answering and perception. A comprehensive review of 180 benchmarks evaluates MLMs across various dimensions. The study focuses on perception, cognition, reasoning, and specific domains. It also highlights key capabilities and explores other modalities. The paper discusses current evaluation methods, limitations, and future directions. The authors argue that evaluation is vital for MLM development. For more information, visit their GitHub repository. Discover the latest in image segmentation technology. Researchers introduce SAM2UNet, a powerful tool for versatile image segmentation. SAM2UNet uses the higher backbone of SAM2 as its encoder and a classic U-shaped design for the decoder. Adapters are cleverly inserted for efficient fine-tuning. This innovative approach outperforms specialized methods in tasks like camouflaged object detection and medical image segmentation. The project page offers more insights. The paper is a technical report in the field of computer vision and pattern recognition. Explore the full text for more details. Meet xGen-MM, also known as BLIP3, a new framework for large multimodal models. Developed by Salesforce, it includes curated datasets, training recipes, and model architectures. These models are rigorously tested on various tasks, showcasing strong in-context learning. The pre-trained base model stands out, while the instruction-tuned model competes well with other open-source LLM. Cerebra's inference is powered by the third-generation wafer-scale engine. All models, datasets, and fine-tuning code are open-sourced to advance LLM research. Discover more on their project page. Researchers explore the impact of code in pre-training large language models. They investigate whether including code data enhances performance on non-code tasks. The study evaluates models with parameters ranging from 470M to 28B. Results show that code data significantly improves general performance. It boosts natural language reasoning by 82%, world knowledge by 4.2%, and generative win rates by 6%. Code performance sees a 12x increase. The study concludes that preserving code during pre-training positively impacts model performance. Researchers at Johns Hopkins University explore the link between pre-training and fine-tuning of large language models. They fine-tune various checkpoints of a model, observing performance on 18 datasets. Key findings: continual pre-training subtly enhances models, revealing benefits post-fine-tuning. Tasks the model struggles with during pre-training see significant improvements. However, models may forget previously known domain knowledge during supervised fine-tuning. Interestingly, models show high sensitivity to evaluation prompts post-fine-tuning, but this can be reduced with more pre-training. The study sheds light on the dynamics of model training, suggesting potential for cost-effective training with less pre-training.